Welcome to Real Civil YouTube channel. In this video, I am going to show you how to solve the problem of axial deformation. I am also going to tell you one trick that will be very useful while drawing the free body diagram. So first I will read the question. For the loading diagram shown in figure, determine the deformation in the bar. So we have to determine the deformation in the bar AD. Okay. The modulus of elasticity and the cross-sectional area is given to us. So here you can see the bar AD, which is divided into three sections AB, BC and CD. The forces are as shown and the lengths are also shown here. So very first step is to draw the free body diagram accurately. So we have divided the bar into three sections. First one is the AB, second one is the BC, and the last one is the CD. Okay, now the trick is, first part of the trick is you have to show the forces at the start and at the end as it is. That means we will show the 50 kilonewton and 30 kilonewton as it is. Okay, now for this 50 kilonewton, we will show a reactive force opposite in nature of 50 kilonewton. Okay, I think it is clear till the first part. Okay, now second part is very important and very interesting. Now here you can see at the in the problem at the junction B there is a force of 30 kilonewton acting towards left. Okay, so you have to show this force on the right side. That is, here we have B two times. Okay, so you have to show on the right face. Okay, so I will show here. I will not change the magnitude or even direction. So this is 30 kilonewton. Okay, now for this 50 kilonewton, again there will be a reactive force of 50 kilonewton. Now take the right force positive and left force negative. So 50 minus 30, which it will be equal to 20. So show this force here, 20 kilonewton. Okay, so this 20 kilonewton, the opposite nature force we will show here 20 kilonewton. Right, now this 20 kilonewton we will show here 20 kilonewton. Okay, now again at the junction C, we have a 10 kilonewton force acting towards the right. So again you have 2C. So as I told you, you have to show this force on the right face, that is on the right side. So this is 10 kilonewton. So as I told you, this is positive, this is negative. So 10 plus 20, it will be 30. Now you can see the we have determined or we have drawn the free body diagram correctly. So next part is very easy. We have to determine the deflection in the bar AD. So for that we have to determine the deflection in bar AB plus deflection in bar BC plus deflection in the bar CD. Okay, so we know the formula, that is P1 L1 upon AE, as A and E are constant, so we can write AE, sorry, here P2 L2 plus P3 L3 upon AE. Okay. Now I can take the common AE, and in bracket for the first section, that is AB, here you can see the 50 kilonewton load is there, and which is compressive in nature. So that's why my sign will be minus 50 into the length. Length is given here, you can see 1 meter. Again, this 20 kilonewton, that is BC section, 20 kilonewton compressive force is there. So minus 20 into the length is given 1.25. Again, this 30 kilonewton is compressive. So minus 30 into 0.6. So that will be equal to 1 upon. So the area is given 5 centimeter square. So 5 into 10 raised to minus 4. So that the answer will be in meter square into E is given 200 GPa. So into 10 raised to 9 multiply by, if you solve this section, you will get minus 93. So if you solve, you will get minus 0.93 meter. So that is the deflection of the bar. So this is how you can solve this problem. So very important is we need to draw the free body diagram correctly. I hope this part is clear to you. If you have any doubt, you can ask me. I will surely reply. Thank you. Thank you so much.